Hey guys, so welcome back. So what we have here is a power supply, a DC power supply that will run between 6 volts and 12 volts DC. This is from about, I don't know, late 50s, early 60s. If I know better, I'll put it in the identification here. I got this for a project or two that I have to work on, and it provides a lot more output power than the lab supply I've been using for DC. So it has, as you can see, it's in pretty rough condition. I got it off eBay a couple of months ago, and I'm going to give you a quick tour around, but I have had this open because I wanted to use it. I wanted to give it a quick once over, and when I saw what was inside, I stopped and I thought I want to maybe do some replacement. So I ordered some parts, and then it kind of got off the bench for a while, and we're getting back into it. So I'll show you what I found, and then we'll see what we're going to do about it. As you can see, it's in looking at the monitor, it looks better than it does in person. It looks a little bit more like that in person, but if you look at it with a camera, wow, look how beautiful and spotless that is. Yeah, it really isn't. But anyway, the case is kind of what you might expect. These were sold as kits. I suppose they could have also been factory wired. I know they're available both ways in some cases. But anyway, we'll get into it. It has a broken off cover for the lens here. It's got a range of voltages. Look how precision that is. These are Eico gauges. They are not adjustable from the outside. So what I will do when I use this is I'll probably have external meters hooked up rather than relying on these. Unless I'm using this as a battery charger, which I don't plan to. It's got a fuse in the front, which is very useful. Is that the right size? It's nice. It says 5 amp right there on the front. That might be a 5 amp. I'm going to leave it out because I'm going to check it later to make sure. So let's get this thing open and we'll take a look inside, and I'll show you what I found. One of the first things I noticed is that the cord is broken here at the strain relief, right? So I'm going to replace the cord. Alright, let's get into this thing. It only had one screw in the back. Yeah, let me show you what I found. Okay. There's the cover. It's not too bad, really, considering the age of it. So you can see it's been out in the garage or something for a long time. It's pretty dusty on the inside. And, you know, it probably was made as a kit. Here's all the diodes for the bridge rectifier that are there. And I did quite a bit of checking on this. I'm going to take me a while to refigure out what I was doing. So let me flip this thing upside down. And you'll see a lot of electrical tape here. So I have the schematic for this. All right, this is a model 1064. I have the schematic for a 1064S. I looked at them online and I couldn't see a difference other than the 1064S did not show that these two switches throw together, and the numbering of the diodes was slightly different. It looked like they had 2 CR2s or something like that, so they corrected it. But everything else about the layout is the same, and most importantly, the values of the electrolytics are the same, and that's what I'm going to talk about. Alright, so there may have been some variety in the way these things were shipped in terms of the parts. Maybe the parts list didn't always match, but this was taped on here kind of like so. And I cut the tape off because this shows 2 capacitors on either side of the choke, okay? And what we have here is we have 4 capacitors. So I thought, well, what's going on here? Also, in case you just want to know, I mean, this is a bridge rectifier. It's got a switch depending on how many of these you go through. It's got a thing like here that operates it. Anyway, so when you get out over here, here's your voltmeter across the outputs. Here's your ammeter with a variable shunt for measuring the current going through here. You switch it whether you're on the 10 amp or the 20 amp. Well, they switch together with the voltages here. If you're at 12 volts, it'll go to 10 amps. 6 volts, it'll go to 20 amps, I guess. All right, so let's get back into this. This is the thermal cutoff. All right, so let's look at what we have here, right? So we should have two electrolytics at 5,000 microfarads each at 20 volts. All right, so what we have here, so I believe this is the choke. This is the let's see if I got that right. No, sorry, this is the transformer and this is the choke. All right, so let's get these capacitors out of here. Okay, well, let me bring it out this way. All right, so what you'll see is 4 capacitors. And look how they've been wired together. The hookup wire. And you see all the commons are tied together. And it runs off with this wire here. And then you have these 2 wired together and these 2 wired together. And this is hooked up to a yellow lead. But you also see a yellow lead here that's just cut and free swinging. Now over here, turn it around, you'll see these 2 leads go off. One of them is to the ground set up here, and this other one comes to this pair. Well, I think this one used to come over here somewhere, but instead there's another wire that goes off to another location. Now, I want to make a couple comments about this. One of them is I think whoever did this knew what they were doing. Okay, I think the workmanship of this is actually very good. Okay, so I don't think somebody did a hack job on this, really. You can see where they had like a pad down here to isolate it or insulate, how you want to say it. Of course, I'm holding this upside down, so this kind of went like this. Actually, I don't remember. It may have been like that. I guess it was like that. And to keep it from shorting, I think it's actually a very professional job for what they're going to do. But let me show you why I wanted to not use it right away. So I'm going to push these guys out of the homemade holder that this person made for this. I mean, I'm actually very impressed by this. Okay, I think I've pulled it out enough for you to kind of see what the issue is, or what I'm concerned about. How big of an issue is it? I don't know. Maybe it's not that big an issue. Okay, they're free. Take a look at this. You had a piece of cardboard folded up, piece of cardboard folded up, same thing here, and then they wrap the thing all up. I mean, actually, I think that's pretty cool. I actually like that. They used nice wire. It's like Teflon coated wire or Teflon insulated wire. But here are the caps. And you can see this is where I stopped. Okay. These are 1500 microfarad caps. They all are. Okay, so they're wired such that they would be double that. They'd be 3000. So instead of 2 5000s, I'd end up with 2 3000s. You know, okay, but still not quite as much filtering as this thing is, was designed to have. Was that a retrofit design? Was somebody published something in Popular Electronics that this is a better way to go? I don't know. Because the other question is what about that yellow wire that was cut off? So the other thing I remember is that one of these caps is in the right place and the other one is in a different location. So, and that's where that yellow wire got cut. Okay, so let's take a look at what we have here. This yellow wire that's cut goes to the common of that switch. Okay, so which is the common of the switch? Okay, one is for voltage. Okay, so here's I said thermal. This is the breaker. Okay, so here the white lead comes up and goes to that right there. So I believe that's here. And then we go on the other side of this to the bridge, which we do. It goes from here, the other side of the breaker goes to the bridge. Okay. But one of those clear Teflon wires goes to one of the bridge locations. So, and one of the bridge locations looks like it's, I don't know, it seems like I remember one of these may have been moved, or maybe I was trying to figure out what it was. And that was when I said, well, look, what I'm going to do is I'm just going to stop what I'm doing and I want to get the right capacitors. so that I can get this back on spec. Okay, so what I did was, in the intervening couple of months, I had a reason to put in an order for Mauser, and so I've got a couple of 5,000 microfarad caps at 25 volts. Okay, and this is calling for 20, so I'll be okay with that. So I've got a couple of caps. The only ones they had that were what I wanted were not radial, they were axial. All right, so I'm left with putting these in. All right, so I have the right specification capacitors, so I could just go ahead and cut these out and wire this up in accordance with this and move on. But I just thought it'd be kind of interesting to look at this first and see what were they doing. Is there, and maybe a question I'll ask you guys, is that, am I missing an upgrade that was worked out for this unit to change where this is wired? And we'll see, we'll find out. But if you guys know, I'd appreciate knowing. All right, so let's see, this one pair here, if I remember right, is actually going where it's supposed to go. So this one looks like it's going to the positive post. Okay, so that's this one. Okay, so what I want to do is put a mark on there so I can keep track of what I'm looking at here. Okay, so this is the one that's the second one that goes to the output. Okay, that pair there. So that was C1A. So C1B is this other one. Okay, C1B is supposed to be wired on the other side of the choke. Okay, oops, I'm sorry. So that was C1A that I just put the tape on. Okay, this other one, C1B, is supposed to be wired on the other side of this choke. But let's see where it's wired instead. I know I was following the yellow wire, but let's follow the Teflon wire instead. Okay, so that Teflon wire, that's the ground. Teflon wire comes off, it's here. Okay, it goes here. And so it goes down here to the bridge. Okay, so that's the positive of the bridge, goes to this diode right here. I'm coughing because it's kind of dusty in here and it's getting everywhere. Alright, so let me see, which bridge component is that? Well, let's see where it goes. It goes from here to here, from here it goes up to there, and it goes to a switch connection. But it does not go through the breaker. Where's the breaker? Breaker's here. So the breaker comes off of this set. So this is the opposite set. So I beg your pardon, it doesn't go there. They've got it wired there. Leave some comments on why you think they would have done it that way with half the capacitance, and not half, but nearly, and have wired it this way. Now, is there any reason why that wouldn't work? I don't know. I mean, it seems like to me that this is more your traditional pi filter. I'm wondering if we should just test it and see how it works. Why not? I don't think it would hurt anything. All we're doing is looking at filtration. Let's look at it. We'll do an experiment. We'll hook this thing up. I'll put a load on it, and we'll just take a look at the see how it performs. Let's see how we want to have this. Okay, it actually wants to sit like that. So what I'll do is I'll put this in like what? Like so. Yeah, I'm going to re-secure it like he had it. I mean, give the guy credit. I mean, I think that I think this is pretty good. And it's interesting that the electrical tape was used to hold this to location, but there's an older tape here that's like masking tape. And it may have been how this sort of thing was held in here originally. It may be the original masking tape. I don't know. Okay, I'm going to put him back into this and remount it as the guy who did this last had it. And like I say, give him credit. I mean, I think he did a pretty decent job for what he's doing here. You know what I'm saying? I mean, that's That held that pretty solid. Who knows how long ago that was done. Okay, so this can go in like this, and I need to secure that. Let me get some tape and I'll tape that up. This is just temporary, guys. I just want to do a test. I'm going to change the power cord out at least. Okay. That's got it held really well. Okay. And just in case something gets flying around loose, I'll cover the voltage point. I'm not talking about high voltage here, but I wouldn't want, you know, full current running through this either in the wrong place. Maybe wreck the meter or something. Okay. Maybe there's this 85-year-old guy watching this that says, "Hey, that's mine." And he's, "What are you doing?" I'm sorry, sir. Okay. So let's see here. Here's the power cord. Yes, it's got a little problem, but I'm going to be careful with it. I'm going to run it on my isolation power supply with a dim bulb tester, so I don't think we're going to get into too much trouble with that. So let's see. Before I plug it in, let me get an ammeter set up and a voltmeter set up and a load on here. So let me come, and I'll come back when I get that done. Okay, so what I've got set up here is I've got AC power to come in. I'll plug in this into my panel here in just a moment. The panel's got a 10 amp fuse on it. I'll be able to read the AC volts going in. Up here out of sight is I have a isolation transformer, a dim bulb. Let me put the bulb in the circuit, and I've got a variac. I'll bring the voltage up slow, turn the variac down. So I'll then plug this in. I've got this set up to be an ammeter on the 10 amp scale. It is in series between the black and the red, which you'll see coming up here. I have a 12 volt seal beam headlight here. Then that goes into the ground connection. I have the next lead hooked up to the low beam side of the headlight. That then comes into the positive here. Meanwhile, I've got a couple of leads here. This one and this one are going to this meter. So this meter will be showing us the voltage. These will be backwards, of course. So this will be the voltage out, and this will be the ammeters coming, the amps coming in. If you can kind of keep that straight, it's going to be this and that. I don't expect this to be very accurate. I don't think there's any adjustment for it, and I'll always use these anyway, so it's cool. All right, so let me plug this in. I did check the fuse. It is a 5 amp fuse, so I've put it in. Power is not on yet. Non-polarized plug, I might comment. Okay, my system's set up. I'm going to turn on the power, and I'll be watching the dim bulb up here you can't see. Hey guys, this is Mr. Future back with you again. So here I am editing this. We're in February of 2023 on something I recorded back in September of 22. And as a public service, I'm going to cut down a lot of this testing here, both to save time, but also to just avoid going off on a red herring that I ran into here to do with my test equipment. So I'll explain that in just a second. But in summary, what we did here is we ran this test, and we brought the line voltage up slowly to make sure we didn't have any shorts. And what we learned is that we did not have any shorts at all, so that worked good. The unit itself functions in principle. The good news is that there was no humming from the transformer at all. In fact, it's very silent. The bulb that's on the load would glow and react to the voltage changes that we put into it. But on the bad side is that the Eico ammeter there on the Eico unit itself in the upper right hand does not work at all. But the thing that was a real problem is the red multimeter you see me using there as an ammeter was not working as an ammeter. It was letting the current go through it, but it wasn't recording it correctly or at all. And so this caused some real problems while I was doing this test, because I was under the impression I wasn't getting enough current through the unit. I became concerned with my power capability, which had me running down a path that we don't need to go explore here, because there was a problem with the meter. So here's a picture that I just took a few minutes ago where you see I'm running my DC power supply running, was that say 8.3 volts, going through a load resistor you see there in the front. And I've got these two multimeters in ammeter mode wired up in parallel, sorry, in series. And you can see that in one case we're reading 7 milliamps, but the fluke is correctly reading on the order of 1.9 amps. So later on in the testing, you'll see I'll reverse these two. I just checked that Craftsman meter. The 10 amp fuse seems to be fine. I don't know what's wrong with it, but I can only use it for volts, I guess. And so I'll reverse those and that'll fix things. But the bigger issue that we found here is that there's a problem with the voltage control knob on the Eico unit. And I'm just beginning to discover that issue here at the end of the test. And so what I'm going to do is just drop right back into the test as we're starting to look at that. So let's continue on. Well, it went into a trip of some kind. What happened? Did it overheat? Is that the breaker? Maybe this has got a rough spot in it? By the way, the neon light never lit up. Still not showing any amperage per se. That doesn't make sense to me, but anyway. And it's hit the max on here. I was hoping that would go a little bit higher. Yeah, I think that switch has got a little bit of a problem. Okay, so that's actually about where I would like for this to be, is 14.4. Yeah, there's something wrong with the switch in here. So I've switched this over to 6 volts. I've taken the dim bulb out of the circuit. I've got the voltage turned up to about what it normally is here at the house. And I've got a 12 volt bulb with both low beam and high beam hooked up. This is measuring the voltage. So if I bring that on up, I mean, I'm definitely getting glow here. So I've got that all the way. The knob is a little shaky, but I'm only getting to 5.5 volts. And it says I'm only moving 100 milliamps. There's no way that that's a half a watt, right? I'm going to take this, strip this back out, and I'm going to put this on spec, and we'll see how this performs then. I think that we'll need to do that because this isn't going to work for my purpose anyway if this is the way it's going to perform. So let's tear all this down, then I'll start doing the changeover of the capacitor. Yeah, it may be more of a problem with the switch here, the rheostat, or the way the transformer works, than it is the capacitors. See, now I'm pulling the full 100 milliamps, but that's still nowhere near. I mean, I want to be, I want to be like 6 amps here. Let me look at this and see if I can find a way to get in there and clean those contacts or something. I'm not sure what's going on in there. I know that there's a way that the transformer windings get wiped different amounts is what's going on. It's not a rheostat. And see if there's a way to get in there and get some cleaner in there or something and try to clean that up. But because right now this isn't going to do for my purposes. It's not these I'm reading, it's these I'm reading. And that's not enough. And it's obviously got a problem with this knob, with this control. Okay, let me start getting into here and we'll see what we can find. This is bolted into these brass standoffs, and they appear to be like attached to spot welded studs or something coming off of this faceplate. So what I think I can do is I can loosen the transformer up, and I think it'll separate from the wiper mechanism, which is down in there. It looks like a rheostat, but I think it's rubbing directly on the windings of the transformer. So I'm going to let you see in there. As I turn this, you can see part of it moving there, right? So I think it's got a couple of wipers that are in there rubbing on windings, and I can't see them, but I want to clean them. All right, so let's see. Let's see them this way. Not really, but it's in there. I can't see if you're seeing anything, guys, sorry. But it does wobble around. See, now I'm moving it. Can you see that? See how that's moving around? So it's kind of sloppy fit. So what I want to do, I'm going to take these capacitors out anyway. I want to get them out of the way. Then I'm going to loosen these bolts and see if I can pull this transformer back and see if it actually separates from that wiper mechanism. And then if so, I can get in there and I can clean them, and then maybe I can tension them and we'll get better connection, and then maybe we'll get a better performance. I don't know if I'll put these caps back in at that point just to compare to see if it made a difference. We'll see when I get to that point. But meanwhile, we get the capacitors out of the way, and then we'll see if we've got this transformer, if we can pull it back. All right. Y'all thought I was going to leave that on there like that, didn't you? As Indiana Jones said, you know what a careful guy I am. All right, let me get these out of here. I actually really like how the guy did that. That's actually pretty cool. I remember that. This has been epoxied or whatever, so it may not want to come out because this is holding the laminations together too. Okay, well, I'm having difficulty getting this out. These are all lacquered over. I'm not sure if it wasn't shipped for the factory. This already assembled this plate, or this one was built at a factory. I can see down inside of there the contacts, and I see how they move with the front here. I'm going to take the front off and just see what we can discover there. Probably not much. No, nothing. So move around, and that's about it. Tightening making any difference? It's not loose. I could probably get in there and clean those points, but what I want to do is I want to get in there and stiffen them up a little bit too, so that they bear a little harder. That wobbling is definitely part of the problem, and that won't go away just cleaning the contacts. Well, I'm going to do it. We'll see what we get. Do I know how to do it? We'll see. I'll bring you back when I get all these things off. Okay, I fought my way through getting most of these things off, and I'm going to have to unsolder this to get it loose, but I think that the plates, the items in the back are trying to come loose from the front plate, so I had a good time getting these guys loose. I'm going to go take a break. Doug, here's the wrenches. Would you mind getting that off? I'll be back in a minute. Okay. Hey, thanks, Doug. Appreciate you getting that off for us. All right. Well, see what we see. See if this gets us anywhere. Okay. Okay, it looks like it's willing to move. I don't know how far I can go before I pull the wire. I've still got to deal with this. Is that going to get me what I want to see? I don't know. Let me get this unsoldered and then we'll get that out of there, and then we can take the front panel off and at least get it cleaned, right? For what? Taking it to the auction, obviously. Some other poor guy deal. Alright, let's see. Okay. Well, we achieved what we intended to achieve, I guess. We'll see if this is... Careful what you wish for, right? So how's this held in there? Yeah, it's spot welded or something in place there, isn't it? You can see it. Is that a Phillips head? That's not a Phillips head, it's a straight head. So what's keeping me from coming out more? Force. Okay. Let's go after those guys right there. And these are holding the transformer onto this plate. You got a sign, put my name on here? I probably will. Just kind of like put a note on here that says something like, why are you looking here? Why are you looking in here? Okay, we're getting close. Still got a lot of other wires hooked up to this. I'm trying not to have to redo everything. Okay, so, oh, they are separate. Okay. Let me turn you where you can see. Can you see? Sorry, the transformer is a little heavy. Ah, you can kind of see the transformer is separate. Let's take a look and see what we got here. So that's what we're doing, is wiping on those faces of that winding. Okay. Now, does it matter where this was? Yes, I believe it does. I believe it was facing this way, like that. Okay, what I'm going to do is I'm going to make a mark, just because I like to make witness marks there and there to remind me, you know, what the way that point setup was set up, there and there. Okay, you can see the points right here. We're going to clean those, and then we're going to put a little bit of bend in these to give them some extra push. And then we're going to clean this up here. Do you think these have just been sanded to get the winding off? I don't know. We're going to clean them. I think I can clean them with alcohol. I got some 99% isopropyl. I don't think that attacks the coating on the windings. Interesting design. So it kind of goes like that. It changes the ratios. That's really interesting. do you think? I think I'm going to use just a little bit of sandpaper and freshen it up. Okay, I've got some 220 here. Just going to freshen it up just a little bit. I'm not going to use anything stronger than alcohol as a solvent on here because I don't want anything to go after the windings. I'm sure there's something else I could use, but I think this will be fine. Okay. Okay, that looks better. Okay, now we'll figure out what we're going to do with these contacts. I do want to tension them more, and I want to clean them. Let's see, when this is tight, they still wanted to kind of move around, but that's okay. I just want to probably pinch them forward a little bit, just to give them a little bit of that, right? But I also want to clean the contacts. For that I can use contact cleaner. I may put some deoxit on those as well. Deoxit red. Let me clean them first. Okay, I want to look at the surface of those. They look like they might be conical. Yeah, they're slightly domed. Not too much. This one's got a lot of arcing on it, looks like. Here. You can see that. Yeah, you can kind of see it there. Half of it's kind of got a burned look to it. This one up here doesn't look too bad at all. A little bit on the outside. This one has more. I think what I'm going to do is burnish these just a little bit. I guess I can just use a little bit of the sandpaper on them. I think, is that a problem? No, it'll be okay. I'm not doing anything but just removing some of that surface oxidation that was definitely on there. That looks a lot better. Okay, let's go to this one here. Yeah, that burned place is already gone. A little bit of a pitting there, but I don't think it's going to be a problem. Okay, those look much better, don't they? Alright, let me get the fire hose out here. This is just going to go onto the contacts only. Thanks Tony for pointing out to us the evils of this stuff being used incorrectly. Okay. So now what I want to do is I want to give them a little bit of a squeeze. So that they run a little tighter. Okay. I'm just eyeballing this. Okay. So now this will go in. I'm just going to double check to see if it looks like I like the amount of squeeze it's got. Put this in. This just runs around like this. Let me put this back on. I didn't actually have to take that off. But thanks anyway, Doug. Okay. All right, let's put this up against it and see how the squeeze is. Get where I can see if I like it or not. That feels a lot more engaged. And as I wobble the knob, I know you guys can't see, but the contacts aren't really moving as I'm doing that. I'm going to give it just a little more squeeze and then call it good. Okay, what I'm going to do is I'm going to take the opportunity to clean the faceplate while all these controls are off of it. And then I'll bring it back when I start to put this thing back together. I do believe. At least we'll have the control will act a little better. I'm not sure how that'll affect everything else, but we'll see how it does. And we'll get this thing in pieces, don't we? Let me see what I can do to clean this up a little bit while I got these controls out. What do you know? It looks better cleaner. I was worried it's going to lift the decals off, but it feels like they're paint, silk screened. Well, what do you know? That's looking pretty good. I might do more. Yeah, I've made a clean spot now. I'm going to have to take the gauges out and everything. I'm going to cut you off and I'll bring you back later. Finish getting this thing cleaned up, huh? All right, I'm going to get this cleaned up and I'll bring you guys back when I'm done. Before. After. Yeah, it looks better. So that'll pop into there. I've cleaned the gauges as well. And the knob. Yeah. I guess I won't be too ashamed to have this in the house. It looks pretty good. Well, rather in the lab, in the shop. All right, I still got a lot of cleaning to do. Okay, I'm ready to restart the assembly. I've got one screw started just to kind of get us going here. And let's get the rest of us put together. Okay, just got that started. Got lots of squeeze on the contacts, I hope. Feels like it. Okay, we will see. In case you're wondering, man, that's the wrong way. I'm doing that on purpose. I want it to drop into that last thread so I don't cross thread it. Can you see that? It popped in, and then I knew I could turn it back to the right. Feels very solid on the turning. I think we got good contact now. I can wobble this plate, but the contacts are not moving. Okay, that's good news. Okay, so we got that fixed. I don't know if that was what was causing the problem with everything, but it wouldn't helping. We saw that when we adjusted it, we were getting surges of extra current through there. So it was definitely causing some resistance across the contacts. We did not want. Okay, I'll make sure these are nice and snug. Alright, we have a number of things to put back in. I mainly want to get that in so I wasn't pulling on the wires. Okay, so one of the things we've got is that this neon bulb in here, right here, has lost its lens, and I'm going to replace it. Rather than using a neon bulb, I've got an LED that I'm going to put in that place. I believe it was probably amber colored, and so that'll fit into here. This is already prepared for 120 volts, 125 volts right here. So what I'm going to do is, as you know, neons have to have a resistor for once this kicks on to prevent that. You know, you got to have some resistance here for flowing, but this isn't requiring that. So what I'll do is I'll cut this lead. I'll leave the resistor there, but I'll just joe from here to here, and that'll give us our neon light, and I'll stick that in. And I'll do that pretty soon here, as soon as I decide nothing else is going to be in the way from me doing that. Then we're going to change the power line, power cord. The question is do I use a polarized plug or do I use a three conductor? Well, it's, you know, it's isolated. It has an isolated power supply, so the outputs are isolated from the mains, and there's nothing going to the chassis. So I don't think I need to do any of that. So I think I can just use a regular 2-conductor cord. Will I make it polarized? Well, I don't really have to, but I can make it to where the hot lead goes to the switch. I'm going to leave the fuse where it is. I'm not going to worry about it. I don't think it matters. So I'm going to put a new cord in, so I don't have this problem here. The other thing I could do is put the original cord back in and just, you know, choke up on it, so to speak. Get rid of this one and then put this one in, and then I'll have the original cord. So question is why not? I don't think I have a problem with it, because it doesn't really need to be polarized. The cord feels okay. I'm going to do that. I'm going to keep the original cord. I'm just going to cut this out, and then I'll put the new one in. The advantage of this is I have the right size grommet. Boy, that really puts a bite on those things, doesn't it? I'd do face plant into my phone. That'd be awesome. Alright, so basically I need this to be from there to there. Sure wish I had a pair of parallel jawed pliers. You mean like these? Very cool, huh? Okay. Okay. That ain't going anywhere. Alright. So one of these goes to the fuse, which will be here, and the other one will go down here to the switch. What I'm going to do is go ahead and get the faceplate back on, so I can go ahead and start assembling the switches and so forth on here. So let's get that done. That looks pretty nice. And that looks nice too. So let's get this thing put back together. Okay, so I think that looks better. Whatever was here kind of ate through a little bit, but it looks clean at least. Glad I remembered to check that. Oh no. Oh, dude. These got to come off. God. Jeez. Jeez. I'm going to get there eventually. Okay. How are we looking? Not too bad. Yeah, double check a few things, make sure I know what goes where. I believe this is going to go down there to the bottom lug of this, and then this will be where the power line will go. I'm going to double check these things. And then what I'll do is I'll hook up the LED between here and instead of going here to go through that resistor, I'll just put it into here, and that's where the LED will run. Okay. Hope this works. It's got like a couple of items here that wedge in. Okay. There. It went in all the way. And it looks okay. Yeah, I think that looks good. Okay. So one of these legs will go up here, and one of these will come down here to this switch. So yeah, the card was full. I didn't realize it. But anyway, I've made a lot of progress here on the front, as you can see. It looks pretty good. And we can kind of go ahead and start finishing up what we've got going on here. So let's see, I've got the power line connected on one side to the switch. I need to connect this up here to this point up here. and connect this to the fuse here, and then we'll be left with dealing with the capacitors. So let me just go ahead and do that. I'm going to cut the camera off and just get those things done. Bring you back. Okay, so I finally got this built back. It took a while, I must say. So we got the fronts ready to go. Alright, got all the connections back in. They're all nice and solid. Got the new cord in. The new power cord is terminated to the fuse and to the switch, as it should be, and I'll address that later. And now what I've got is, for the two capacitors, I've got the common. I'll cut this to length, and then I've got a lead for each of the two positives that are on either side of the choke. Alright, so now I've got to figure out how I want to mount the new capacitors. I'm going to give that some thought, and I'll be back after I figure out a plan. And probably after I wake up tomorrow morning. Alright, see ya. Okay, I've got it all put back together, and I'm ready to put the new capacitors in. Now, you remember I was talking about how the fella who had modified this had made like a holder for these, and the way it was made with the cardboard wrapped around. Well, I was looking for a way to how to mount these new capacitors, and I thought that's actually a pretty good idea. So I did the same thing. So the way these are, we've got a couple of these 500 microfarads. These were smaller. Now I know maybe there's an issue with ripple current. You know, heck, I'm just going to try them out and see how they work. So I've got these things mounted in here. I'm going to try this as a way to mount these. Obviously I got the negative terminals marked, so if I'm worried about it. So now the question is how to mount this in here. This is upside down currently. I'm going to try to think about how that's going to take to hold it in here best. The way he had it was he had them strapped up against the back here. I'm a little concerned about the fact that these are not radial, these are axial, so I've got some leads to protect here, but I'll come up with something here. Okay, I'm looking at the power that's available out of this, and what I'm thinking about doing, just out of course, is check these diodes that are part of the bridge circuit. I've tried testing them provisionally with my multimeter here, but I'm not sure if I'm getting good readings because of the way they're all connected. Best thing to do is to raise a lead on these. I have more hookup wire that's this size, so I think what I'm going to do is find the minimum number of these and just cut them to verify I have good performance of the diodes, and then if they are, then I can just use some hookup wire and J-hook them back together, and that'll be okay. But at least hook this up to where I can get good isolated tests of these. I'm going to do that, and I'll come back and let you know what I found. Okay, I've got at least one leg lifted for each of these diodes. That was lifted entirely. That one is lifted here and here. This one, I guess I didn't need to separate that one, but because this one is lifted. So basically, I've got it to where at least one leg is completely isolated. This one's completely isolated. Both of these are, both of these are, both of these are, and both of these are. So they're all isolated on both sides except for the connection of these two windings here. So this one's not completely and that one's not completely. That's okay. I'm just going to check from here to here and here to here. So what I'm going to do is go through first and just check for things being reversed. You know, flowing the wrong way, shorted. So what I'm going to do is put the negative on the anodes, which is the, unless these are backwards, right here on the tip of the stud. And can you see? Okay, that looks okay. I'll do it the right way around. 0.471. So that one's good. Let's go to this one. Negative on the top. Nothing there. Reverse them. That one's good. So now we'll go to this one. Negative on the top. Nothing. Reverse them, positive on the top. That one tests good. Now I'll go to this one here. Positive on the top, should be okay. Okay, reverse it. Okay. Diodes test okay. I'll get those wired back on where they go, and I'll put a splice in for that one I just cut off. Yeah, just because I'm a suspicious guy, I also check to see if this is wired correctly. And I believe it is. So I'll just go through it real quick. So this is, I would number this 1, 2, 3, 4. So it's 1, 2, 3, 4 using this diagram. Okay. So I think what we're going to have, I'm not sure the easiest way to show this, but let me just put it this way. So we have a transformer winding comes out and goes to the anode of 1. That puts us right here. Come out of the transformer winding, we go to the anode of 1. We also go to the cathode of 2. So I go here, I have a jumper that comes from here and goes to the cathode of 2. Okay, that's correct. Let's follow that direction. So from here we go from the cathode of 2 to the anode of 2. The anode of 2 is here. It goes to the breaker. Anode of 2 goes to the breaker. It also goes to the anode of 4. So it comes here, it goes to the anode of 4. 1, 2, 3, 4. So that's correct. So from the anode of 4 we go to the cathode of 4. The cathode of 4 should go to the other coil winding, and it should go to the anode of 3. So let's see, we go here. It goes to the cathode of 4, goes to the anode of 3, and it also goes to this, let's see, anode of 3, and the cathode of 3 then goes to the switch and the cathode of 1. Switch, the cathode of 1. So that's the correct wiring sequence. Now I'll hook it all back up. Okay, I've got this rehooked up back as it was. I spliced this in with a piece of 12 gauge single strand rod, which is basically what's in there. And so I got that spliced in. So that's rehooked up like it was. All right. So now what I'm going to do is think about how to get the capacitors in there. I got a couple ideas, but I'm going to have to probably fit and fiddle with some things to get an idea of how I wanted to get it in there. The other thing that I can do, I left it in the other room, I do have a modular bridge rectifier that is rated for 50 amps and 1,000 volts. So I mean, this is only going to get 110 or thereabouts, and it will definitely work for this application. If I finally get around to the application I want to work this on and I'm not getting enough through this, I might consider changing these. These might only be 10 amp. I don't really have the parts list. I've seen people say they might be, I don't know, 10 or 20, 15 or 20 amps. I'm not sure which. They may not be enough, but we'll just see how it goes. I originally was thinking I couldn't use it, but of course I can. I could definitely use a monolithic bridge rectifier. Just go AC here to here and then DC between these two. Any rate, we'll continue on with this and we'll see how it goes. Let me get the capacitors in there. That won't affect if I want to change something here or not. So let me get on with it and then we'll see. Those look like a couple of good mounting holes. I'm thinking about having this mounted in this orientation. So I'm thinking of a way to use these two holes, I'll right back to screw out of there just for measuring. That's the bracket that holds the diode plate on. I could put another plate on the other side and come down this way. This is from my hoard of stuff. This is from an old inkjet printer that I gutted a long time ago. I thought maybe I could use this someday. This is steel, as this is. I checked it with a magnet. So I think I might be able to utilize this. Maybe one of these types of configurations where the leads are not going to get in the way. Let's see, actually I'd have that go the other way. So this would kind of go in, there you go, something like this. I've already got a couple of places here where I could put some zip ties through here to hold that. So let's see. I'll use that. I measured it. That's 7/8 of an inch across there. So, but basically I just need a piece. There's the hole spacing right there. About like that. So maybe I'd take this to, say, here, and here. So maybe try to cut that like that. And then bring this on up. Let's see, do I need that? Let's see. Yeah, I might want that. Slice it there. Slice it through there. Yeah. And maybe I'll just take it like that and then fine tune it. I know I'm probably going to need to cut that off though. But anyway, let me just cut this out here and then see how it fits. Okay, I think that screw will be long enough. Yeah, I think so too. Because I'm going to put one of these on there and that'll lock it. Okay, so now we've got to figure out how we're going to attach this to here. And it'll actually end up being in this orientation. Gravity in this direction here. That landed buttered side up. Can you believe it? Need to go buy a lottery ticket. Positioning it over that hole to give it something to bite into on the slick metal surface. See? Okay, we're going to let that dry. It's raining outside. Okay, this has been on for about 15-20 minutes. It's supposed to be a 5-minute set. Of course, it takes 8 hours or so to fully cure. Yeah, it's not coming off on my fingers or anything, so I think I'm ready to start trying to see how this is all going to go in there. Now the idea is this is going to go in to here. And then we use these tie wraps to hold the capacitors in this position here. So that's the reason why I wanted this on here, is to keep this from sliding off. I think that when this bites into this cardboard, that'll hold it well enough so that it won't slide this way. Now in terms of the capacitors, I think that's got pretty good hold on it, but I will do something more than that. I look back at my inspiration for this, which is what another fellow had done. And what he did was he just took some tape and went across here and then used a band going around this way to secure those ends down. I'll do the same thing on this. I'll just take a strip of this this tape and bring it across here and across here, and I put a band across it, and that will really hold it well. I've also got this insulative covering on it. I guess it's fiberglass, woven fiberglass. And you know, remember, we're only talking about 12 volts here, guys, so that's not going to be an issue. I just don't want to short out against anything else. So what I'll do is I've got this labeled in case another person comes along later. There's two 5,000 microfarad 25 volt DC caps in here, and I think I showed this before, but here they are. You know, silver is always the negative, and I went ahead and put a negative symbol on it. There's positive. So I'm doing this because they won't be able to see it otherwise, because it'll be soldered in, at least initially. So I'll put it in like that. I will shorten these, tie them together after I put the tape across it, and then I'll put these together, probably bring it out this way and put them together, and then they'll get tied onto this line here, which goes to the negative post. And then these I'll bring in, I'll shorten all this up and tie on J-hook to each of these and put some shrink tubing on it. And then I'll put that in there and tie wrap it. And the idea of doing the tie wrapping is then, you know, it's easy for someone to go in there and cut the tie wrap and pull this out, and then they can slide these around and see what they are. I guess I'll make it to where they can pass it out this way and see what it looks like. But they have to cut this band, but that's okay. We know if it needs being done, it can be done. Like that. And I'm just going to use one of these Keps nuts on here. One of the things I noticed is when I'm working on a radio, at least when I'm doing a lot of the work, I got something to listen to. When I'm working on this, it's kind of quiet in here. How's that look? That's pretty good. Won't interfere with the housing. Okay. Okay. That's solid. Okay, now what we want to do here is I want to try to get some tape go through there. Okay, I'm satisfied that is going to prevent them from slipping out. Okay, those caps are in there, they're not going anywhere. Okay, so now what we're going to do is take these leads and give them a bend where they're not going to be tugging too close to the outlet here. About there. Like that. So that's the negative lead. I want them to go up here like this. And go right in there. Now, as you can see, this piping is covering it. I'm not worried about that, but I might put some tape over the top of it just because, but I think I've got enough to where it's not going to touch. Bring this down. that. Bring this down like that. All right. Make it to where it's not quite touching. So I'll bring those together and then I'll tie the negative onto that point there. So let's see here. Yeah, see, that's in a good spot. That'll hold it right about the middle of the stack, so that'll be fine. Don't know if the one will do it. It would help if I did that the right way. I was relieved to see that wasn't glued in. Okay, that's engaged. And I'm going to let that be kind of right there. That's got a good bite on it. It's not going anywhere. That's the support frame flexing. See the whole frame flexing there. All right, so that's sturdy. All right, let's finish the wiring on this thing, huh? I'll bring it back when I get all these attached. Okay. Plenty of room. It's not anywhere near those screws. Okay, ground's done. Negative that is. Now, these two guys. And there we are. There's plenty of room up against those screws. There's no problem not touching. Good. Okay, let me get this thing buttoned back up and then we'll see if it still works. Okay, here's the last look at what we did here. So we got those routed around okay, out of the way, not on each other. I routed this a little bit differently since that was just on a screw post, so I undid it and brought it around this way. So it's on there, got that on. And I think this thing is ready to go back into the case. We can give it another test run while it's still open and make sure we don't have any shorts or anything. Okay, we got it all back together again. I'll hook it up like I did before. It'll go through the isolation transformer. One thing I did differently is I swapped these two. I think this one just seems a little more robust in terms of the amperage for running all the current through it. So this one's going to be reading amps. I've got it on the 10 amp max here. This one will be reading DC voltage, and it's picking up right up here across the terminals. I've got this hooked up to the high side, high beam side of the sealed beam. And I think we're ready to go. So I'm going to go ahead and turn it on. And I've got the bulb into the circuit again. Okay, now it says I'm getting 2 volts. Let's see that, okay. 2 volts out, running 1.8 amps. I'm getting a much different reading now, aren't I? The bulb is lit. Watching the dim bulb. You can see the dim bulb is taking a toll. 3 amps. Okay, there's 6 volts. I've got a 4 amp fuse in my panel, and this is a 5 amp fuse, but that would be for 12 volts. I'm sorry, for 120 volts. Let's see what I'm moving on the 120 volt line. About a half an amp. You can see the voltage is dropping through the dim bulb. See, this will be on the 10 amp scale, which is scale here. So this says we should be about 1 amp, and we're actually at 3.4, so we can't trust this gauge. Okay, what I'm going to do is let's sit here a sec. But then what I'll do is turn the voltage down, and we will switch the dim bulb out of the circuit. But what I'll do before that is I'm going to turn it down and then switch to the 6 volt scale, make sure everything's okay on that scale. Okay, so as you can see, the bulb is glowing. Let me turn it down. Current's dropping off. 6 volt scale. These wires are warm, as you might imagine. Yeah. Okay, we're at 6 volts, 3.5 amps. And then of course I can turn the voltage up. But I'm doing this just to make sure we don't have a short in that circuit either. That all looks good. So I think what I'm going to do is go ahead and turn this down, and then I'm going to bypass the dim bulb, and we'll go at full voltage. Bypass now. 120 volts, 300 milliamps. Okay, so 6 volt scale. Here we go. We're at 6 volts. This is a 12 volt bulb, so we can keep going up. So this is current at this voltage. This is 5 amps, and that is 4 amps at line, which is this. And we're still only pulling about 600 milliamps on the line, so this should be okay. So we're at 8 volts. Almost 4 amps. Okay, so I've got that pretty much all the way 9 volts, 4 amps. It's supposed to be able to go to 6 volts, 20 amps, but that may be held back by this. Okay, so now what I'm going to do is turn this back down, and we're going to go to the 12 volt side. Go to 12 volts. I think this bulb should be able to handle like 14 and a half volts. Got quite a bright light here. Okay, we're at 12.6 volts, moving almost 5 amps. Should go to 10. I'm going to go to 16 volts. 16 volts. Pulling 5.5 amps through here. Okay, so I'm going to do one more test here for high current. I found online more information about the ratings of this, and here they are. The 6 volt range goes 0 to 8 volts, 10 amp continuous, 20 amp intermittent, and 12, as you can see, is 0 to 16, 6 amp continuous, 10 amp interim. And so what I thought I'd like to do is I'd like to see if I can provide a larger load for the 6 volt range and see if I can get 5.5 amps out of this. So that's what we're going to do now. So what I've got is I have 2 seal beam bulbs here. These are both 6 volt bulbs. I have this on a 6 volt scale. I'm using some larger size conductors, as you can see here, and these are wired in parallel, as you would like different lights and loads you would have on your switches in your house. So the wattage of this will add to the wattage of this, so that I won't have it hold the voltage down so much, but I'll be able to get more power draw on this, more current draw is what I guess I'm trying to say. Alright, so what we have here is I come out of the negative lead. The negative lead has 2 green leads that go to the grounds of each of these. The positive lead is going to go through this, which is set in the amps position. And I got to be careful because this is a 10 amp max on this. It's got a fuse in here for 10 amps. Okay, I come out of here and I've got a clip lead that's really only holding the lead from this against that 12 gauge piece of wire there. From there it goes into the meter here and comes out the black lead. The black lead then has these 2 red leads on it that then each take a load to here. So as you can see, all these clip leads are carrying half the load. The only thing that's taking the full load are the leads to my multimeter, which is taking 10 amps is the maximum rating. This is simply to measure the voltage once again, and it's clipping on here and it's clipping on here. So that's just measuring the voltage out of this. Okay, so the intention of this is to see how much current we can get out of this, and we'll see what we get. Alright, so I've got it 120 volts. I do not have the dim bulb in, it's bypassed, so that the current isn't holding back on this, on the voltage coming in. Alright, so can you see this okay? Nearly? Okay. Here we go. 0 power coming on. Okay. So we're going to watch DC voltage here. That's in millivolts right now. And then we're going to watch amps here. So we're coming up. Okay, we're currently at almost 2 volts, 2.3 volts. And we're already at 6 amps. So this actually just put the juice out, doesn't it? 8 amps. Okay, we're at 5 volts at 9 amps. And I'm getting a glow on this one and a bit of a glow on this one too. So this doesn't seem to glow as brightly, but you can see it's glowing there. Turn the lights off. Does that work? There you go. So I'll go ahead and come up some, but I have to watch my current here so I don't blow the fuse in my ammeter here. So basically what I'm going to try to do is go up to 10 amps or 6.3 volts, whichever is most. Or whichever gets there first, I guess I should say. Okay, I'm at 10 amps. So it'll run 10 amps. I've still got more room to go on here. So I'm almost to 6 volts. So I think that's pretty good. If I disconnect one of these, well, those leads are hot. Okay, now we're down. Now we're up to 7.5 volts, and there I am at 6.3. Okay, so I can go 6.3 volts at 5.7 amps, and that's actually fine. What I'd like to have is 6.3 volts at 5.5 volts. So that's going to serve me for what I need it for, as you can see, and it'll handle even more power than that. Too bad this gauge doesn't work. This one's not too far off, but this one's pretty lousy. But anyway, it's working and doing what I need it to do. And yeah, these wires are very warm. Okay. Turn it down, and since I have these loads, that'll drain my capacitors. One more thing, I wanted to see how the ripple looked. Bring this back up. And I don't know if maybe the capacitors need to form up some or not, I don't know. I'm going to go back to that 6.3 position. Alright, that's perfect. Turn the oscilloscope on and we'll see what we get. Okay, so we're right a little over 5 volts, which is what we'd expect to see. So let's see if we can pick up the ripple here. I don't see much. Let's go to AC coupled. Okay, there's our ripple. So if that's 0.2, we're about 0.1. Let me see, let's get that full point peak to peak, make it a little easier. So let's say we're at 0.1.5 for fun. So we're 0.075 volts. That's pretty good. I'm happy with that. So there you go, guys. I think this thing's going to work out really just fine for what I want to do. It can go up to 6 volts, 6.3 volts. It can give me 5.5 amps and more, a bit more, and I think it's going to be perfect for what I need it for. We looked at the ripple. I think if I got this right, let's see. We had like from here to here, we were at 0.2 volts, and I was probably about to here, so let's call that 0.15 volts, and that was peak to peak, right? So that would mean that I am at 0.075 volt peak, and if I want to get to RMS ripple, then I would multiply that times 0.707, right? And let's see what that gets us. Bear with me as I pull my calculator up, because I'm not going to try to do it in my head, right? As if. Okay, so let's see, that is 0.075 times 0.707. Okay, is 0.053 volts RMS. And then if I divide that by the volts we were running, which is 6.3 volts, divided by 6.3 is 0.0084. All right, so multiply that by 100. You want to see it that way, and so that is 0.84% ripple RMS. I think that'll work just fine for what I need. All right, so there you go, guys. This is the Eico 1064. The schematic I had said S. I've seen some people say 1064 is the original one that had a selenium rectifier. This one obviously had silicon diodes in it. And but meanwhile, we got the new capacitors in here. The ripple's acceptable. I think it's really, really good. This is a great unit. I'm glad to have it on my bench. And I'm also glad to have you all along watching me dig into this thing and get it back to life and where we can put this thing to work. And anyway, so thanks again for stopping by. Appreciate it. Thanks for hanging out with me. See you next time. Thanks. Bye.